We often take the ground beneath our feet for granted, seeing rocks and dirt as simply part of the scenery. But what if these abundant resources held the key to a more sustainable and profitable future? What if we could transform these ordinary materials into extraordinary products, unlocking their hidden value and revolutionizing industries in the process? This is the promise of innovative smelting technology. By harnessing the power of carefully controlled heat and advanced extraction methods, we can unlock the potential within rocks and dirt, transforming them from overlooked elements of our environment into valuable resources. The journey from raw materials to valuable products begins with a deep understanding of the potential hidden within rocks and dirt. These seemingly simple substances are, in fact, treasure troves of essential minerals and elements. Rocks, particularly those rich in silicates and oxides, can be transformed into durable construction materials, while the diverse mineral composition of dirt makes it ideal for smelting into a wide range of industrial byproducts. The smelting process itself is a marvel of controlled energy and precision engineering. By carefully managing temperatures and extraction stages, we can isolate and harvest specific elements with remarkable efficiency. This process allows us to maximize the value derived from every ounce of raw material, minimizing waste and environmental impact. Beneath the surface of the Earth lies a hidden world of geological wonders, a treasure trove of minerals and elements waiting to be unlocked. Rocks and dirt, often dismissed as mundane components of our environment, hold within their structure the building blocks of countless industries and applications. To fully grasp the potential of smelting, we must first appreciate the remarkable diversity and value embedded within these seemingly simple materials. Rocks, formed over millennia through geological processes, are not uniform masses, but complex mixtures of minerals, each with unique properties and potential uses. Igneous rocks, born from the fiery heart of volcanoes, boast high concentrations of silicates, the foundation for durable construction materials. Sedimentary rocks, formed from the gradual accumulation of sediments over time, often harbor valuable minerals like limestone, essential for cement production. Metamorphic rocks, transformed by heat and pressure deep within the Earth's crust, can contain rare elements and gemstones prized for their beauty in industrial applications. Silicates, a group of minerals composed primarily of silicon and oxygen, are the most abundant minerals in the Earth's crust, forming the basis of many common rocks, including granite, sandstone, and basalt. Their abundance, combined with their inherent strength and durability, makes silicates an ideal raw material for a variety of construction applications. Through the controlled heating process of smelting, we can extract silicates from rocks and transform them into a variety of building materials. At temperatures exceeding 1,100 degrees Celsius, 2,012 degrees Fahrenheit, silicate minerals begin to melt, allowing us to mold and shape them into desired forms. While often overlooked, dirt, with its complex blend of minerals, organic matter, and microorganisms, holds surprising potential for various industrial applications. Through careful processing and extraction, we can unlock the hidden value within dirt, transforming it from a readily available resource into a source of valuable byproducts. One of the key advantages of dirt as a raw material lies in its diverse mineral composition. Depending on its origin and geological history, dirt can contain significant amounts of aluminum, iron, calcium, and other valuable elements. Through smelting, we can extract these elements and repurpose them for a wide range of industrial uses. For instance, aluminum, a lightweight and corrosion-resistant metal, is extracted from bauxite, a type of soil commonly found in tropical and subtropical regions. Iron, a fundamental component of steel and other alloys, is extracted from iron ore, a type of rock often found in sedimentary deposits. Calcium, essential for cement production, is derived from limestone, a sedimentary rock formed from the accumulation of marine organisms over millions of years. Beyond its mineral content, dirt also harbours a wealth of organic matter, which can be harnessed for various purposes. Our journey into the heart of sustainable smelting begins with the careful preparation of raw materials. Rocks and dirt, freshly excavated from the earth, arrive at the processing facility brimming with potential, but requiring a series of transformative steps to unlock their hidden value. The initial stages of the smelting process focus on removing impurities, concentrating valuable components, and preparing the material for the intense heat to come. The first stage involves a gentle heating process, gradually raising the temperature to around 100 degrees Celsius. This crucial step serves to evaporate any water content within the raw material, ensuring a dry and more manageable feedstock for subsequent processing. Removing moisture is essential not only for optimizing the efficiency of the smelting process, but also for preventing potential explosions or steam buildup within the high-temperature furnaces. As the temperature climbs beyond the boiling point of water, the organic matter present in the dirt begins to combust. Between 200 and 500 degrees Celsius, decaying plant matter, microorganisms, and other organic components break down, releasing carbon dioxide and leaving behind a more concentrated mineral mix. This controlled combustion process not only removes impurities, but also contributes to the overall energy efficiency of the operation, as the heat generated can be captured and reused in subsequent stages. With the raw material dried and purified, we embark on the next stage of our smelting journey, the targeted extraction of valuable minerals. This phase involves a delicate dance of temperatures, carefully calibrated to exploit the unique melting points of different mineral components. By precisely controlling the heat within the furnace, we can selectively melt and separate specific minerals, transforming a heterogeneous mixture into a stream of valuable products. As the temperature climbs to 825 degrees Celsius, carbonates begin to decompose, releasing carbon dioxide. This CO2 is captured for industrial use or sequestration, contributing to a more sustainable process. At around 1,100 degrees Celsius, feldspar begins to melt, separating from the remaining solid material. This molten silicate solidifies into durable construction materials, such as bricks and tiles. Section 3. Tapping into the heart of the earth. Metal extraction and beyond. Venturing deeper into the heart of the smelting process, we reach temperatures where even the most resilient materials begin to yield. At this stage, our focus shifts to the extraction of metals, those essential elements that form the backbone of countless industries and technologies. The intense heat of the furnace, now exceeding 1,500 degrees Celsius, or 2,732 degrees Fahrenheit, unlocks the bonds that hold metal atoms captive within the Earth's crust, allowing us to harvest these valuable resources and harness their unique properties. Metal oxides, compounds formed from the reaction of metals with oxygen, are the primary targets of this high-temperature extraction process. Iron oxide, for instance, a common component of iron ore, breaks down at these temperatures, releasing molten iron that can be collected and processed into steel and other essential alloys. Aluminum oxide, another abundant metal oxide, requires even higher temperatures to melt, but the resulting molten aluminum is lightweight, corrosion-resistant, and highly versatile, finding applications in industries ranging from aerospace to construction. Section 4. A symphony of heat and transformation, the final act. As the smelting process reaches its crescendo, the molten rock, now a swirling symphony of liberated elements, undergoes its final transformation. The intense heat of the furnace, having unlocked the bonds that held minerals and metals captive for millennia, gradually subsides, allowing the molten material to cool and solidify, taking on new forms and revealing its hidden potential. The cooling process is carefully controlled, just as meticulously managed as the preceding heating stages. The molten material, guided by channels and molds, begins to crystallize, its atoms arranging themselves into ordered structures as the heat dissipates. This controlled cooling is crucial for determining the final properties of the solidified material, influencing its strength, durability, and suitability for various applications. For instance, rapidly cooling molten silicate can produce glass, a versatile material with applications ranging from windows and bottles to fiber optic cables and laboratory equipment. Slower cooling, on the other hand, allows larger crystals to form, resulting in a more crystalline structure that contributes to the strength and durability of materials like bricks and tiles. Section 1. From Waste to Resource. The Alchemy of Emissions Capture. The transformative power of smelting extends beyond the realm of rocks and dirt, encompassing even the byproducts of the process itself. Emissions, often viewed as undesirable waste products, are, in fact, valuable resources waiting to be harnessed. Through innovative capture and processing techniques, we can transform these emissions from environmental liabilities into valuable industrial assets, embodying the principles of a circular economy and minimizing our overall impact. At the heart of this transformation lies the concept of industrial alchemy, the ability to transmute seemingly undesirable substances into valuable products. Just as alchemists of old sought to transform base metals into gold, modern industrial processes strive to convert waste streams into valuable resources, closing the loop on production and minimizing our reliance on virgin materials. Emissions capture is a multifaceted process, employing a variety of technologies tailored to target specific gases and particulates. Scrubbers, for instance, are commonly used to remove sulfur dioxide from exhaust streams. These devices spray a fine mist of water or a chemical solution into the exhaust gas, trapping the sulfur dioxide and converting it into a more manageable form, such as sulfuric acid, a valuable industrial chemical. Carbon dioxide, often demonized as a primary contributor to climate change, is, in fact, a versatile molecule with a wide range of industrial applications. By capturing and utilizing CO2 emissions from the smelting process, we can transform this often maligned gas into a valuable resource, reducing our reliance on fossil fuels and contributing to a more sustainable future. One of the most promising applications of captured CO2 lies in enhanced oil recovery. In this process, CO2 is injected into mature oil reservoirs, where it dissolves in the remaining oil, reducing its viscosity and allowing it to flow more easily towards production wells. This technique not only increases oil production from existing fields, but also provides a safe and permanent storage solution for captured CO2, effectively trapping it underground. Beyond its role in enhanced oil recovery, CO2 is also a valuable feedstock for the production of a variety of chemicals and fuels. For instance, CO2 can be reacted with hydrogen to produce methanol, a versatile chemical used in the production of plastics, resins, and fuels. Similarly, CO2 can be used to synthesize formic acid, a key ingredient in many industrial processes, and dimethyl ether, a clean-burning fuel for transportation. The principles of sustainability extend beyond the capture and reuse of emissions, encompassing the entire smelting process and its integration within a broader industrial ecosystem. By embracing a closed-loop system, where waste streams are minimized and resources are continuously recycled and reused, we can create a more efficient and environmentally responsible approach to industrial production. At the heart of a closed-loop system lies the concept of waste as a resource. Rather than viewing byproducts and emissions as undesirable outputs to be disposed of, we can reimagine them as valuable inputs for other processes, creating a circular flow of materials and minimizing our reliance on virgin resources. The heat generated during the smelting process, for instance, is a valuable energy source that can be captured and reused within the facility. The practical applications of our smelting technology extend far beyond the laboratory and the factory floor, reaching into the very fabric of our built environment. The materials derived from this innovative process possess unique properties that make them ideally suited for a wide range of construction applications, paving the way for a more sustainable, durable, and aesthetically pleasing future. Bricks and tiles, those fundamental building blocks of civilization, take on new life when crafted from smelted silicates. The intense heat of the smelting process fuses the minerals into a remarkably strong and homogeneous material, surpassing the performance of traditional clay-based bricks in several key aspects. Smelted bricks are known for their exceptional durability, resisting the ravages of weather, erosion, and even fire with remarkable resilience. Their uniform shape and smooth surface allow for precise construction and reduce the need for mortar, further enhancing their structural integrity. Beyond bricks and tiles, smelted aggregates, produced by crushing and grading the solidified slag byproduct of metal extraction, offer a sustainable alternative to traditional gravel and crushed stone in various construction applications. Section 2. Beyond bricks and mortar. Industrial applications and market demand. The industrial applications of our smelting technology extend far beyond the realm of construction, encompassing a diverse array of sectors hungry for sustainable, high-performance materials. From the automotive industry's demand for lightweight, durable components to the electronics sector's thirst for rare earth elements, the byproducts of our smelting process find a receptive market eager to embrace innovation and reduce its environmental footprint. The metals extracted from rocks and dirt through our carefully calibrated smelting process are in high demand across a wide range of industries. Steel, the backbone of modern infrastructure, relies heavily on iron ore, a readily available source of iron that can be efficiently processed using our technology. Aluminum, prized for its lightweight yet durable nature, finds applications in aerospace, automotive manufacturing, and packaging, reducing weight and improving fuel efficiency. Section 3. A profitable paradigm shift, economic and environmental benefits. The adoption of our innovative smelting technology represents more than just an incremental improvement in industrial processes. It signifies a paradigm shift with the potential to reshape entire industries and unlock a future where economic prosperity and environmental stewardship go hand in hand. From a financial perspective, the profitability of our smelting operations stems from its ability to transform readily available low-cost raw materials into high-value products in high demand across various sectors. The efficiency of our process, combined with our commitment to minimizing waste and maximizing resource utilization, further enhances profitability, reducing operating costs, and maximizing return on investment. The environmental benefits of our approach are equally compelling. By capturing and reusing emissions, we minimize our contribution to air pollution and greenhouse gas emissions, mitigating our impact on climate change and improving air quality. The reduced reliance on quarried materials minimizes habitat destruction and preserves natural landscapes, while the use of renewable energy sources further shrinks our environmental footprint. Section 1. Reshaping the landscape. Tunneling through mountains with ease. For centuries, mountains have stood as majestic yet formidable barriers, separating communities, hindering trade, and challenging the very notion of efficient travel. Traditional tunneling methods, often slow, costly, and environmentally disruptive, have done little to alleviate these challenges. Imagine a future where innovative smelting technology reshapes the landscape, transforming mountains from obstacles into opportunities for connection and progress. Envision a world where tunneling through even the most challenging geological formations becomes as effortless as tracing a line on a map. Controlled heating and material extraction techniques, honed through years of research and development, could allow us to precisely melt and remove rock with unprecedented speed and efficiency. The intense heat generated by mobile smelting units, powered by renewable energy sources, could weaken the bonds holding the rock together, allowing for extraction with minimal blasting and disruption to the surrounding environment. Section 2. From obstacle to opportunity, on-site material repurposing. The benefits of our smelting technology extend far beyond the mere act of tunneling. The excavated rock and dirt, rather than being discarded as waste, are transformed into valuable resources, further enhancing the sustainability and cost-effectiveness of our approach. This on-site material repurposing embodies the principles of a circular economy, minimizing waste and maximizing resource utilization. As the molten rock and dirt are extracted from the tunnel, they are channeled into a mobile processing unit, a marvel of engineering efficiency. Here, the molten material is separated into its constituent components, each with its unique properties and potential applications. Silicates, the building blocks of many common rocks, are separated and cooled, solidifying into durable aggregates that can be used directly in the construction of the tunnel lining, roadbeds, and other infrastructure components. Metals, liberated from their oxide bonds through the intense heat of the smelting process, are collected and processed on-site, ready to be shipped to factories and workshops for further refinement and transformation into countless products. The rare earth elements, often found in trace amounts within the Earth's crust, are carefully extracted and concentrated, their value far exceeding the cost of extraction and contributing to the overall economic viability of the project. Section 3. A network of sustainable passage. Connecting communities, transforming travel. Imagine a future where a network of sustainable tunnels crisscrosses the globe, effortlessly connecting communities, facilitating trade, and transforming the very experience of travel. This is the vision driving our continued innovation in smelting technology. A future where mountains, once formidable barriers, become gateways to new possibilities. These tunnels, far more than mere conduits for transportation, would serve as arteries of sustainable development, fostering economic growth, enhancing connectivity, and promoting environmental responsibility. Remote communities, long isolated by challenging terrain, would gain access to markets, educational opportunities, and essential services, bridging the gap between urban centres and rural areas. The environmental benefits of this interconnected network of sustainable tunnels would be profound. By shifting transportation underground, we could reduce our reliance on airplanes and trucks, both significant contributors to greenhouse gas emissions. Electric trains, powered by renewable energy sources, would whisk passengers and cargo through these tunnels at high speeds, minimizing travel time and reducing our carbon footprint. Section 1. The Earth Transformed. From raw potential to sustainable progress. From the rugged landscapes to the bustling cityscapes, the Earth beneath our feet holds the key to a more sustainable and prosperous future. What we once perceived as inert and mundane, rocks and dirt, are, in fact, treasure troves of potential, brimming with the building blocks of a brighter tomorrow. Through the transformative power of sustainable smelting, we can unlock this hidden value, reshaping our world and redefining our relationship with the very ground we stand on. Imagine cities rising not from quarries and concrete plants, but from the very earth on which they stand, their structures bearing the strength and resilience of the earth itself. Imagine tunnels carving paths through once impassable mountains, connecting communities and fostering economic growth, all while minimizing our impact on the environment. Imagine industries thriving on a closed-loop system where waste is minimized, resources are maximized, and emissions are transformed from liabilities into assets. This is the promise of sustainable smelting, a future where innovation and responsibility converge to create a world that is both prosperous and sustainable. Section 2. A call to action. Embracing the future of sustainable smelting. The journey towards a future shaped by sustainable smelting begins with a collective shift in mindset, a recognition that the Earth's resources are not ours to squander but to steward for generations to come. It requires a willingness to embrace innovation, to challenge conventional thinking, and to invest in technologies that hold the potential to reshape our world for the better. This is a call to action for entrepreneurs, investors, policymakers, and citizens alike to recognize the transformative potential of sustainable smelting and to champion its adoption across industries and communities. It's about supporting companies that are pioneering these technologies, advocating for policies that incentivize sustainable practices, and making conscious choices as consumers to support products and services that align with our values. The road ahead is not without its challenges. Transitioning to a more sustainable industrial model requires significant investment, technological innovation, and a willingness to embrace new ways of thinking. Yet, the potential rewards, economic prosperity, environmental sustainability, and a brighter future for generations to come, far outweigh the challenges. The Earth has provided us with an abundance of resources, and for too long, we have taken these gifts for granted, exploiting them without considering the consequences. Sustainable smelting offers a path forward, a way to harness the Earth's bounty while minimizing our impact, ensuring that the legacy we leave behind is one of progress, not depletion. The future is in our hands, and the time to act is now. Let us embrace the promise of sustainable smelting and build a world where innovation and responsibility pave the way towards a brighter and more sustainable future.